Hey guys, how's it going? Welcome back to another video in the Intro to Coding series. In this one, we're going to go over inheritance. Inheritance basically means that you can have a class inherit information or methods or types, a bunch of stuff from another class. So I checked my analytics on YouTube and about 64% of you are not subscribed. So please consider subscribing. It's free and really helps the channel grow more. So just quick little shout out. It's just down over here. Thanks. Now, let's jump into some inheritance. Boop. All right, so you might notice that we have our class from last time, the person class. It's slightly different. I just kind of copied it down and changed a couple things here. We have this age doubler class just for fun, or method, sorry. You might notice we also have this describes a person kind of string right up here, which is kind of cool. I didn't really go over last time, but what you can actually do is go person.doc and print out basically what is your class supposed to do. So kind of a neat little thing. It's just kind of useful. It's like a comment, I guess you could kind of think of it, but it's actually a comment that you can access from your code, which may not be needed, but kind of cool. So we're just going to leave it there for now. Now, we're going to jump into inheritance next. So we have person here, but what is another type of person? Another type of person that is commonly used in programming is the idea of a student. So let's create a class for student. Now, one of the things you might realize with a student is that a student is really just a type of person, right? So we have, we'll still create our init function, and we'll get the self, but we also have a first name. We also have a last name. We also have an age. Maybe we also have like a major or like a class, like this intro to coding class, but let's not use class. Let's use major, because class is a keyword and we don't want to break stuff. So we'll go ahead with doing this. But you might notice like the first three things we have here are the exact same as person, right? So it's kind of not great to just do it like this, because maybe we want this print name where we can print the first name and the last name for a student as well, right? Maybe we also want to be able to double the student's age, or if we want to add the birthday thing that we had last time, we can add that as well. So now, students also have birthdays, so maybe when we want to be able to do that. So what we can actually do here is inherit from the person class, which means that the student, because it's also a person, we can type in person here. And what this means is that student will inherit from the person class. So student is really just a type of person. So instead of just kind of setting all of the values with self here again, what we can actually do is type super, like superhero, and call this as a function, and then do dot underscore underscore init underscore underscore. And now what this means, and we'll type in the first name just so we can kind of show this off, last name and age. Now what this means is super is basically saying, okay, within this init function, we're going to call the init function of whatever we're inheriting from. So in this case, the student is inheriting from the person class. So this line is basically as though we're calling this line. But again, students also have first names, last names, and ages. So we're going to just call this, and it's going to add all of this in here, but we're going to get all of this stuff for free because we already have all this. And we're also saying a student is a type of person. So there we go. So all we really need to do from any of the things that are passed in, the only unique one for students is major. So we can add in major equals major. So let's just kind of show off that this works. Okay, so let's type Jake equals student, and we'll do Jake, we'll do A, we'll do 30, and we'll do coding. Okay, now let's see what our thing we've got here. We've got print name. So let's do jake.print name. Oh, we don't need that. And let's run this here. Okay, we get JakeEh. But you'll notice that this print name isn't in student. It's an inherited function that we got from the person class. So we can call this, we could call this, we could call this, we can, right here, let's do birthday. It'll still be wrong because I'm not 31, so it'll say 30th or 31st. We'll actually see that this fails because I copied this from the wrong thing, where we have it called name, but we'll do first name, and then this will work. So let's run this again, and there we go. Happy 31st birthday, Jake. So yeah, obviously 31st doesn't sound super great, but whatever, that's fine. But still, again, this is a something that is associated with the person class, not the student class. So what if we want to maybe we like the print name, right? We have print name, we'll run print name. But maybe we want to kind of say like, oh, what is this person's like major, or, you know, maybe a description of them or something like that. So another thing we can do here is just create another print name, but this is going to be on the student class. Even though we have print name on the person class, this is something that's called overriding. So you're overriding your parent function or your parent value's name, or your parent value's value or variables. So one thing we can do here is actually type print student, and then we're gonna do a colon space, and then we're gonna do a special thing that you can do with print, where we're gonna say end equals empty string. So what this actually means is that we're gonna print something, but we're not going to print a new line right after it, so that the next thing we want to print will actually be on the same line as this. So let's just add a space here, but just like when we called init, we can actually call the print function from the parent. So we can do super dot print name. So now what this is going to do when we call print name, so when we call print name because it's a student, it will call print name, it will print student on a single line, and then it will call super.printName. And if we go up here, which this will result in printing out the name and then the last name. So let's try this. Student JakeEh, right? Perfect. But if we comment this out and we just print this again, we just get JakeEh, because we're not overriding something. So I've uncommented this now, so we'll keep it with the student because I'm of type student. But again, if I change this to person, and I get rid of coding because I don't have a major as a person, we just get JakeEh. Okay, let's go back to student and let's move on. So far we have been able to call something, the init or the print name, from the parent, but can we also access values from the parent? Absolutely. So say we want to print major, and we'll keep it as self, because everything in a class needs self. Every function in a class needs self. So let's print the person's name. So we'll get self.firstName is majoring in self.major. Okay, so we'll do print name, and then we'll do major. Now, you'll notice that first name is not actually in student, right? It's not defined here at all, but it is actually there because it's within the person parent class that we're inheriting from. Okay, so we got an error here. And the reason for this is because this major, the way we named this, is actually the same as the variable that we have associated with the class. So what we want to we just want to add a print in front of here, and we'll just rename this to print. And then we're fixed there. So let's run this again, and we get Jake is majoring in coding. So again, first name not associated with this class, but pretty cool. So another thing you can do with classes is actually make it so that when you print the class, it actually prints nicer. So again, let's write print Jake, and we will print this off, and we get this main student object blah 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 blah, right? It's just like the directory or the place in memory that the variable is being stored. Not very useful if we want to just print Jake, right? What we can do actually is whenever you do this print Jake, you're actually calling a toString function on an object or on a class. So we can type def str self, and then whatever we return from here is what's going to be printed when we call print. Let's get rid of some of these lines. So let's return, let's just return our name. So we'll do like S, 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 and then we'll do the self dot first, or we'll do last name first, and then self dot first name. You know, let's add the age as well, just cause. And then self dot age. Okay, and we'll add age, just so that it's obvious. Now, when we print this, what's actually going to happen here is we're going to, this being, because it's being printed and it's requesting a string version of this, is going to run this, and we will get, bam, a Jake, or JakeEh. Here, we'll just make this so that it's not as like so fanciful. Last name, and we'll run JakeEh 30, age 30. Great. Now, what if we have one of these instead on, and here, you know what, we'll add a major, and then we'll add self.major, and then we'll add one of these up here, and we'll just do the age, right? So we don't include the major. Now, if we run this, you can see we get coding, major is coding. And again, if we remove this and we run this, we are just going to get the age because this hasn't been overridden because it's a student. So if we remove this, now we're overriding the parent class that we've inherited from. We've overridden their string implementation. So there are a couple other cool ways or cool things you can kind of do for this. For instance, you can say like define add, for instance, and you can say like what happens when I add to a student. So maybe we just say self.age plus equals, we're going to need a variable here, and we'll pass in other. So now we can print out our age here, which we'll have there, and then we will also do Jake plus 1, and then we will print Jake, and let's see what happens. So we've printed here, we've printed the age, and then we've added 1, and then we've printed Jake. And this, when we did this, it means it ends up calling this because we're trying to add 1 to a student, so it ends up calling this. A more useful thing for this though, the most useful thing actually, is how you can define whether two, in this case, students are equal. So we can do self and other again here, and we're gonna see, is one student equal to the other student? So one way to do that would be to say like return, this has to be a true value, so whether it's true or false. So you could say return like self.firstname equals other.firstname and self.last and self.lastname equals other.lastname. Okay, so we'll just say if your first name and your last name match, then you're equal. Okay, so let's just try this, test this out really quickly. So let's create a new Sammy student, and we'll do Sammy, do A, we'll do 4, and master's in barking. Now we'll print is Jake equal to Sammy, and we can print, and we get false. Sammy is not equal to Jake. Okay, but what if we want to make Sammy equal to Jake? If we just change this, and then we run this again, now we get true, because now we are comparing a Sammy student versus a Jake student, and the first name and first name are equal, and the last name and last name are equal. So there we go. If we change this back to Sammy, then again, we would have gotten our false case. Alrighty then, so I hope this shows you how incredibly powerful classes are in inheriting things from other classes. It's super, super cool, and just kind of like the world is your oyster once you start getting into classes and inheriting from other classes. So I hope this was helpful for you. Please leave a like down below. It really helps out. and consider subscribing. Again, getting more subscribers makes me feel all warm and fuzzy inside. So if you like doing that, go for that. And if you really want me to not feel warm and fuzzy inside, then like the video, because that will have that effect, I guess. Anyways, thank you so much. In the next video, we're going to go over iterators, which is kind of a cool way to jump over like lists and things like that. We've done like, while loops and for loops and stuff like that to get over lists, but this is kind of a bit of a more readable, kind of nicer way of doing things. So I hope you enjoyed, and remember, never stop learning. Cheers.